Moscow, 1967. The snow fell silently over the city, blanketing the streets in white as Colonel Viktor Andreevich Petrov walked through the corridors of the Central Research Institute for Precision Machine Engineering. His boots echoed against the cold concrete floors as he made his way toward the classified wing, a folder clutched tightly under his arm. The building, known only by its designation Tisnaya Tokmash, housed some of the Soviet Union's most brilliant weapons engineers, men whose names would never appear in newspapers, but whose work shaped the balance of global power. Petrov had received a call at 3 in the morning. A special delivery had arrived from Hanoi, transported through a network of military channels that spanned half the world. The contents of the shipment had been deemed important enough to wake the deputy director from his sleep, important enough to mobilize a team of specialists on a winter Sunday, important enough to be classified at the highest level. When he entered the laboratory, the package was already on the examination table. It sat there under the harsh fluorescent lights, unassuming in its wooden crate marked with Vietnamese military stamps and Cyrillic handling instructions. Around it stood 4 men in white coats, their faces betraying a mixture of curiosity and professional restraint that Petrov recognized from years of working alongside them. The crate contained 3 weapons, each wrapped in oil-soaked cloth and accompanied by documentation in both Vietnamese and Russian. 2 of the rifles were damaged, their receivers cracked and barrels bent from the violence of their capture. But the 3rd was intact, almost pristine, its black plastic furniture and slender aluminum frame looking almost alien compared to the robust steel and wood constructions the Soviet engineers were accustomed to handling. It was an M16, the American infantry rifle that had become the symbol of Washington's intervention in Southeast Asia. The weapon that Pravda described as the latest instrument of imperialist aggression, but which the men in this room knew represented something far more significant than propaganda suggested. It was a window into the mind of the American military-industrial complex, a physical artifact that could reveal design philosophies, manufacturing capabilities, and tactical doctrines that no intelligence report could fully convey. Dr. Mikhail Kalashnikov was not present that morning. The legendary designer of the AK-47 worked at a different facility in Izhevsk, more than 1,000 kilometers to the east. But his shadow loomed over every weapons development project in the Soviet Union, and the men gathered in this Moscow laboratory understood that their analysis of the American rifle would inevitably be measured against the standard he had established 2 decades earlier. The lead engineer, a bespectacled man named Sergei Vladimirovich Simonov, pulled on latex gloves and approached the table. He had spent his entire career studying foreign weapons, from captured German STG-44s after the Great Patriotic War to British L-1A1s obtained through Egyptian contacts during the Suez Crisis. He had seen innovation and imitation, brilliance and folly, engineering triumphs and catastrophic failures. Yet as he lifted the M16 from its wrappings for the first time, something in his expression shifted. The rifle weighed nothing, or almost nothing, compared to the weapon Simonov had spent his life analyzing. He turned it over in his hands, noting the synthetic materials, the aluminum construction, the small caliber barrel that seemed almost fragile. His first thought, which he would later record in his classified report, was that the Americans had built a toy. His second thought, which came moments later as he began to understand the engineering principles involved, was that the Americans had built something revolutionary. The M16 represented a fundamental departure from everything Soviet weapons doctrine held sacred. Where Soviet designs emphasized reliability through robust construction and generous tolerances, the American rifle achieved its remarkable lightness through precision manufacturing and advanced materials. Where the AK-47 could be dragged through mud, submerged in water and buried in sand, and still function, the M16 demanded cleanliness, care, and regular maintenance. Where Soviet ammunition was large and heavy and designed for maximum stopping power, the American 5.56mm cartridge was small and fast, and relied on velocity rather than mass to incapacitate its targets. These were not merely technical differences. They reflected two entirely different philosophies of warfare, two distinct visions of what a soldier was and what a weapon should be. And as Simonov began his systematic examination of the captured rifle, he understood that his report would need to address not just the mechanical specifications of the M16, but the strategic implications of an enemy that designed its weapons according to principles so alien to Soviet thinking. The first test was simple disassembly. Simonov pressed the takedown pins and separated the upper and lower receivers, a process that took less than 5 seconds and required no tools. The simplicity was elegant, almost beautiful in its economy of design. He had dismantled AK-47s thousands of times, and while the Kalashnikov was certainly simple to maintain, it required more manipulation than this American counterpart. The M16 came apart like a precision instrument, its components separating cleanly along predetermined lines. Inside, the bolt carrier group gleamed with chrome plating, a manufacturing detail that would have been considered extravagant in Soviet factories. The gas tube, positioned directly above the barrel, fed combustion gases straight back into the receiver to cycle the action, a direct impingement system that eliminated the need for a separate piston. It was clever, Simonov admitted to himself. Clever and potentially problematic. He made his first notation in the examination log. The direct impingement system reduced the number of moving parts and contributed to the rifle's remarkable accuracy, but it also deposited carbon fouling directly into the action. In a clean environment with regular maintenance, this would be manageable. In the jungles of Vietnam, where mud and humidity were constant companions and cleaning supplies were often scarce, it could be catastrophic. The other engineers gathered closer as Simonov continued his examination. They measured the barrel, noting its 112 twist rate optimized for the lightweight 55-grain bullet. They examined the buffer spring assembly in the stock, an innovation that reduced felt recoil significantly. They studied the pistol grip and the charging handle and the magazine release, each component revealing something about American manufacturing capabilities and design priorities. But it was the materials that fascinated them most. The lower receiver was machined from aircraft-grade aluminum alloy, a material choice that would have been unthinkable in Soviet weapons design. The furniture was injection-molded plastic, lightweight and impervious to the humidity that warped wooden stocks. The barrel was made from chrome moly steel with a chrome-lined bore, a combination that resisted corrosion and extended service life. Every material choice reflected an industrial base that could afford precision over robustness, that trusted logistics to supply replacement parts and cleaning kits, that designed for the individual soldier rather than the peasant conscript. Simonov paused in his examination and looked at his colleagues. None of them spoke, but the question hung in the air between them, unasked and unanswered. Had the Americans created something superior to the Kalashnikov? Had the capitalists, with their emphasis on technology over doctrine, produced a weapon that could outperform the legendary AK-47? The answer they would discover over the following weeks of testing was both yes and no. The M16 was superior in certain measurable parameters and inferior in others. It was lighter and more accurate, but less reliable in adverse conditions. It was easier to disassemble, but harder to maintain properly. It fired a smaller cartridge that allowed soldiers to carry more ammunition, but delivered less energy at extended ranges. It was a weapon designed for a different kind of war, fought by a different kind of army, under different assumptions about logistics and training and the nature of combat itself. But what truly shocked the Soviet engineers was not any single feature of the M16. It was the totality of the design philosophy it represented. The Americans had looked at the same fundamental problem, how to arm an infantry soldier for modern combat, and had arrived at a completely different solution. They had questioned assumptions that Soviet designers had never thought to question. They had prioritized qualities that Soviet doctrine considered secondary or irrelevant. They had, in short, thought about warfare in ways that the men in this Moscow laboratory had never considered. This realization would echo through Soviet weapons development for the next 2 decades. It would influence the design of the AK-74, the Soviet answer to the small-caliber revolution. It would shape debates about materials and manufacturing tolerances and the proper balance between reliability and accuracy. It would force a reassessment of fundamental doctrines that had guided Soviet military thinking since the end of the Great Patriotic War. But all of that lay in the future. On this winter morning in 1967, the engineers simply stared at the American rifle on their examination table, confronting the uncomfortable truth that their enemy had approached the problem of modern infantry combat from an angle they had never anticipated. The snow continued to fall outside the laboratory windows. Somewhere in Vietnam, American soldiers were carrying rifles identical to the one on this table, fighting a war that would define a generation. And in Moscow, Soviet engineers were beginning to understand that the Cold War was not just a contest of ideology and geopolitics, but a competition between fundamentally different ways of thinking about technology, warfare, and human capability. Simonov reached for his notebook and began to write. His report would take 3 weeks to complete and would run to over 200 pages. It would be classified at the highest level and distributed to only a handful of senior officials. But its conclusions would reshape Soviet weapons development and force a reckoning with assumptions that had gone unquestioned for decades. The M16 had arrived in Moscow, and nothing would ever be quite the same again. Check if you are already subscribed to this channel. Every week, we uncover stories like this one, hidden moments from history that reveal the secret competitions and technological battles that shaped the modern world. Subscribe now so you never miss another revelation from the archives of the Cold War. To understand what shocked the Soviet engineers about the M16, one must first understand what they expected to find. For 2 decades, Soviet weapons design had been guided by a set of principles so fundamental that they were rarely articulated explicitly. These principles had emerged from the brutal lessons of the Great Patriotic War, from the factories of besieged Leningrad, from the frozen steppes where German machinery failed and Soviet equipment endured. The first principle was simplicity. A weapon should have as few parts as possible, each one performing its function with minimal precision required. This was not merely an engineering preference, but a philosophical commitment rooted in the reality of Soviet military organization. The Red Army drew its conscripts from collective farms and factory floors, from the vast expanses of Central Asia and the frozen reaches of Siberia. Many could barely read. Most had never handled machinery more complex than a tractor. A weapon designed for such soldiers had to be foolproof, operable by men with minimal training under conditions of maximum stress. The second principle was durability. Soviet weapons were designed to be abused. They were built with generous tolerances that allowed them to function even when caked with mud, frozen solid, or filled with sand. The clearances between moving parts were large enough that debris could pass through without jamming the action. The materials were chosen for toughness rather than precision, steel and wood that could withstand impacts that would shatter aluminum and crack plastic. The third principle was lethality through volume. Soviet doctrine assumed that individual marksmanship would always be secondary to concentrated firepower. A soldier did not need to hit his target with every shot. He needed to put enough rounds in the general direction of the enemy to suppress and destroy. This meant large magazines, automatic fire capability, and ammunition robust enough to function reliably even when stored improperly or transported roughly. The AK-47 embodied all three principles in perfect harmony. Mikhail Kalashnikov had designed his rifle to be manufactured by workers with minimal skills, operated by soldiers with minimal training, and maintained under conditions that would destroy more sophisticated weapons. The long-stroke gas piston drove the bolt carrier with authority, clearing any debris that might have found its way into the action. The stamped steel receiver could be produced quickly and cheaply, without the precision machining that more advanced designs required. The 7.62-kick 39mm cartridge delivered substantial energy at typical combat ranges and fed reliably from curved magazines that had become iconic symbols of revolutionary movements worldwide. This was the lens through which Simonov and his colleagues examined the M16. And through this lens, the American rifle appeared almost perverse in its design choices. Where Soviet weapons were heavy and robust, the M16 was light and delicate. Where Soviet weapons were designed for illiterate conscripts, the M16 demanded trained operators who understood the importance of regular cleaning and proper maintenance. Where Soviet weapons sacrificed accuracy for reliability, the M16 achieved remarkable precision through engineering tolerances that would be considered dangerously tight by Soviet standards. The weight difference was the first and most obvious shock. The M16 weighed approximately 3.1 kilograms unloaded, compared to 3 kilograms for the AK-47. This difference of 1.2 kilograms might seem marginal on paper, but to men who had spent their careers designing weapons for soldiers who carried their equipment across hundreds of kilometers on foot, it was revolutionary. The implications cascaded through every aspect of infantry tactics. A lighter rifle meant a soldier could carry more ammunition, more food, more water, or simply move faster and tire less quickly. It meant that the same transport aircraft could deliver more weapons to a combat zone. It meant that wounded soldiers could still handle their weapons effectively, that women and smaller-framed men could serve as infantry without being handicapped by equipment designed for Soviet peasants bred for physical labor. But how had the Americans achieved this weight reduction? As the Soviet engineers disassembled the M16 and weighed each component, the answer became clear. Advanced materials, precision manufacturing, and a fundamentally different approach to the relationship between a soldier and his weapon. The upper and lower receivers were machined from 77.5 T6 aluminum alloy, the same material used in aircraft construction. This alloy combined remarkable strength with density, roughly one-third that of steel. Soviet factories could produce aluminum, certainly, but the precision machining required to create receivers with acceptable tolerances from this material was beyond the capabilities of most Soviet manufacturing facilities. The Americans had access to computer-controlled milling machines and quality control processes that simply did not exist in the Soviet military-industrial complex. The furniture, the stock and handguards and pistol grip was injection molded from fiberglass reinforced plastic. Again, Soviet industry could produce such materials, but the consistency and durability required for military applications demanded manufacturing expertise that was concentrated in a handful of American and Western European facilities. The plastic furniture added no weight to the weapon and was impervious to the humidity and temperature variations that caused wooden stocks to warp and crack. The barrel was shorter than Soviet standards dictated, just 20 inches compared to the AK-47's 16.3 inches. But this shorter barrel fired a much smaller cartridge, the 5.56 645mm NATO round that weighed roughly half as much as the Soviet 7.62 cut 39mm. A soldier carrying 200 rounds of American ammunition would carry approximately half the weight of a soldier carrying 200 rounds of Soviet ammunition, a difference that compounded the advantages of the lighter rifle itself. Simonov calculated the total weight difference between an American infantryman and a Soviet infantryman, both equipped with their standard rifles and a basic load of ammunition. The American soldier carried approximately 4.5 kilograms less combat weight. Over a 20-kilometer march, this difference translated to thousands of fewer calories expended, reduced fatigue, faster movement, and greater combat effectiveness upon arrival at the objective. This was the first shock. The Americans had achieved something that Soviet designers had assumed was impossible without unacceptable compromises. They had built a lighter weapon without apparently sacrificing anything essential. But as the examination continued, the Soviet engineers began to understand that this achievement came with costs that were not immediately apparent. The precision machining that made the aluminum receivers possible also made them vulnerable. The tight tolerances that contributed to the M16's remarkable accuracy also meant that the action could be fouled by debris that would pass harmlessly through the loose-fitted AK-47. The lightweight materials that reduced soldier fatigue also reduced the weapon's ability to absorb abuse. Drop an AK-47 from a helicopter and it would probably still function. Drop an M16 from the same height and the aluminum receiver might crack, the plastic furniture might shatter, the precision-fitted components might be knocked out of alignment. And the ammunition, that remarkable 5.56mm cartridge that allowed soldiers to carry so much more, had limitations of its own. The small, fast bullet was lethal at close ranges, where its velocity caused it to fragment and tumble through soft tissue with devastating effect. But at longer ranges, as velocity dropped, the bullet lost its lethality advantage. Soviet doctrine anticipated combat at ranges up to 400 meters. The 5.56mm round was optimized for engagements under 300 meters, reflecting American assumptions about jungle warfare in Vietnam that might not apply to the open steppes of Central Europe. The Soviet engineers documented all of this in meticulous detail. They created charts comparing weights and dimensions, tables analyzing material properties, diagrams illustrating the differences between direct impingement and long-stroke piston operation. But numbers alone could not capture what they were really discovering, that the M16 represented not just a different weapon, but a different philosophy of warfare. The Americans had built a rifle for a professional army, for soldiers who would be trained to maintain their equipment and supported by logistics chains that would supply cleaning kits and replacement parts. They had designed for accuracy over volume, trusting that well-trained marksmen could achieve more with precisely aimed shots than conscripts could achieve with automatic spray. They had prioritized mobility over raw firepower, assuming that the ability to maneuver would prove more decisive than the ability to deliver overwhelming suppressive fire. These were not objectively superior choices. They were different choices, optimized for different conditions and different assumptions about the nature of modern combat. The Soviet approach was not wrong. It was designed for a different army fighting a different kind of war. But the existence of the M16 forced Soviet planners to confront the possibility that their assumptions might not be universally valid, that the next war might demand capabilities their weapons were not designed to provide. The weight reduction that seemed like the most obvious innovation was actually the least important revelation. What mattered was the philosophy behind that weight reduction, the cascade of design decisions that flowed from a fundamentally different conception of the relationship between soldier, weapon, and warfare itself. As Simonov continued his examination, he found himself returning again and again to a single question. The Americans had clearly thought deeply about infantry combat and had arrived at conclusions that challenged Soviet orthodoxy. Were they right? Had decades of Soviet weapons development been guided by assumptions that were no longer valid? Or had the Americans made a catastrophic mistake, designing a beautiful but fragile instrument that would fail when confronted with the brutal realities of sustained ground combat? The answer, he suspected, would only become clear through the crucible of actual warfare. And in the jungles of Vietnam, that crucible was already delivering its verdict. The direct impingement gas system of the M16 became the focus of intense debate within the Soviet engineering team. Simonov had identified it immediately as both the rifle's most innovative feature and its most significant vulnerability. Understanding this system and why the Americans had chosen it despite its apparent drawbacks would prove essential to understanding the M16 as a whole. In a conventional gas-operated rifle like the AK-47, propellant gases are tapped from the barrel through a small port and directed into a cylinder where they push against a piston. This piston is connected to the bolt carrier, and its rearward movement cycles the action, extracting the spent cartridge and chambering a new round. The system is robust and reliable because the fouling produced by combustion is largely contained within the gas cylinder, away from the precision components of the bolt and receiver. The M16 worked differently. Instead of a piston, it used a hollow gas tube that directed propellant gases straight back into the receiver, where they pushed directly against the bolt carrier through a system of gas rings. This direct impingement approach, sometimes called the Stoner system after the rifle's designer Eugene Stoner, eliminated the mass of the piston and reduced the number of moving parts. The result was a lighter weapon with less felt recoil and superior accuracy. But the cost was immediately apparent to the Soviet engineers. Every time the M16 fired, hot gases laden with carbon fouling were injected directly into the action. This fouling accumulated on the bolt carrier, the chamber walls, and every other surface within the receiver. In a clean environment with regular maintenance, this was manageable. In the field, where cleaning might be impossible for days at a time, the accumulation could reach levels that impaired function. Simonov ordered a series of tests to quantify this vulnerability. The examination team fired the captured M16 repeatedly, measuring the buildup of fouling after each 100 rounds. They compared these results to identical tests conducted with AK-47s, tracking the degradation of function as both weapons accumulated carbon deposits. The results confirmed what the engineers had suspected. After 500 rounds fired without cleaning, the AK-47 showed minimal degradation in function. The action was noticeably dirtier, but the generous tolerances allowed the mechanism to continue cycling reliably. The M16, by contrast, began showing signs of stress after just 200 rounds. The bolt carrier moved more sluggishly, and by 400 rounds, the rifle experienced its first failure to extract a spent cartridge case that remained stuck in the chamber when the bolt attempted to cycle. This was damning evidence by Soviet standards. A weapon that could not fire 500 rounds without cleaning would be useless in the sustained combat operations that Soviet doctrine anticipated. Soviet soldiers were expected to function for days without access to maintenance facilities, fighting through engagements that might consume thousands of rounds per man. A rifle that jammed after a few hundred shots was not a military weapon, it was a liability. But as the engineers continued their examination, they discovered that the story was more complicated than initial tests suggested. The M16 they had tested was dirty when it arrived, already contaminated with fouling from previous use by its American operator. When they thoroughly cleaned the rifle and repeated the tests, the results improved significantly. And when they examined American maintenance manuals captured alongside the weapons, they understood that the M16 was designed to be cleaned after every engagement. a standard that would be considered impractical for Soviet forces, but was apparently routine for American troops in Vietnam. Furthermore, the original M16 had been designed for use with a specific type of ammunition loaded with a propellant called IMR 4475, which burned relatively cleanly. The ammunition actually being used in Vietnam, loaded with ball powder, produced significantly more fouling. This was a logistics failure, not a design failure, a mismatch between the weapon and the ammunition that was destroying the reliability the engineers had worked so hard to achieve. The Soviet team also discovered that the M16 had been originally designed with a chrome-plated chamber and bore, features that would have significantly improved fouling resistance and extraction reliability. But somewhere in the transition from prototype to production, this chrome plating had been eliminated as a cost-saving measure. The rifles being used in Vietnam were literally less capable than the rifles Eugene Stoner had designed, degraded by bureaucratic decisions made thousands of miles from the battlefield. This discovery shifted the Soviet assessment in an important direction. The M16's reliability problems were not inherent to the direct impingement system. They were the result of implementation failures and logistical mismanagement. The fundamental design was sound, even elegant. The Americans had simply failed to provide their soldiers with the resources necessary to make that design work under combat conditions. Simonov documented this distinction carefully in his report. The M16 was not a bad rifle. It was a good rifle being used badly. The direct impingement system offered genuine advantages in weight, accuracy, and recoil control. But those advantages came with maintenance requirements that the American military logistics system was failing to meet. The question for Soviet planners was not whether the M16's design philosophy was valid, but whether the Soviet military could afford to adopt similar approaches given its very different assumptions about soldier training and logistics support. If you've watched this far, it's because this story has captured something in you, something about the hidden details behind the weapons and the wars we think we know. Leave a comment saying, "The truth is in the details." Let us know you're here, that you understand that history isn't just about battles and politics, but about the engineering decisions and human choices that shaped everything. The examination of the direct impingement system led naturally to broader questions about the 5.56mm cartridge the M16 fired. This was perhaps the most controversial aspect of the American design, the decision that had provoked the most skepticism among Soviet observers and the most debate within the American military establishment itself. The 5.56 45mm round, originally designated the 2-23 Remington, was developed in the late 1950s for use in the AR-15, the civilian predecessor to the M16. It was, by any conventional measure, an inadequate military cartridge. The bullet weighed just 55 grains, less than half the weight of the Soviet 7.62 39mm round. The cartridge case was small and thin-walled, optimized for weight savings rather than durability. The muzzle energy was significantly lower than that of contemporary military rounds. Soviet ballisticians had dismissed the 5.56mm cartridge as suitable only for varmint hunting, not serious military applications. The conventional wisdom held that infantry rifles needed substantial bullets to reliably incapacitate enemy soldiers, that the energy delivered by small, fast projectiles was insufficient to guarantee stops at combat ranges. The American adoption of such a small cartridge seemed like either desperation or folly, but when the Soviet team examined the terminal ballistics data collected from Vietnamese battlefield reports, they encountered something unexpected. The 5.56mm round was proving devastatingly effective against human targets, producing wounds far more severe than its modest energy levels would suggest. Soldiers hit by M16 fire were suffering massive tissue damage, with small entry wounds and enormous exit wounds that defied the simple physics of penetration and energy transfer. The explanation lay in the bullet's behavior upon impact. The 55-grain projectile, traveling at velocities around 3,200 feet per second at close range, became unstable when it encountered the resistance of human tissue. Instead of passing cleanly through like a conventional bullet, it tumbled, fragmenting into multiple pieces that carved separate wound channels through muscle and organ. The effect was not unlike a small explosion inside the body, producing incapacitation rates that exceeded those of much larger cartridges. This was intentional. Eugene Stoner and his colleagues had understood that lethality was not simply a function of bullet mass and energy. It was a function of how that energy was delivered to the target. A bullet that passed cleanly through a body might kill eventually, but a bullet that fragmented and tumbled would incapacitate immediately. For military purposes, immediate incapacitation was far more valuable than eventual death. The Soviet engineers documented the wound ballistics of the 56mm round with clinical precision, photographing gelatin blocks that had been fired to simulate human tissue, measuring the wound channels produced by tumbling and fragmentation. The results were impressive and disturbing. The American cartridge achieved its lethality not through brute force, but through intelligent design, exploiting the physics of high-velocity impact in ways that Soviet ammunition designers had not considered. But the 56mm round had limitations that the terminal ballistics data did not reveal. Its effectiveness depended critically on velocity, and velocity dropped rapidly as the bullet traveled downrange. At close ranges, under 100 meters, the fragmentation effect was reliable and devastating. At longer ranges, as velocity dropped below the threshold for reliable tumbling, the bullet behaved more conventionally, producing less severe wounds and requiring multiple hits for incapacitation. Furthermore, the small bullet was more susceptible to deflection by vegetation and light barriers than heavier projectiles. In the dense jungle of Vietnam, where clear lines of sight were rare, this limitation was significant. American soldiers reported instances where M16 rounds were deflected by leaves and branches that would not have affected larger caliber bullets, reducing hit probability in precisely the environments where the rifle was being deployed. The Soviet assessment of the 56mm cartridge was ultimately mixed. The Americans had achieved something genuinely innovative in their terminal ballistics approach, demonstrating that lethality could be engineered through velocity and bullet behavior rather than simply mass. But they had optimized for a specific range envelope and specific combat conditions that might not apply universally. A cartridge that devastated targets at 50 meters might be inadequate at 400 meters, where Soviet doctrine expected infantry to engage effectively. This analysis would prove prophetic. In subsequent decades, the limitations of the 5.56mm round at extent 3 weeks after the M16 first arrived in Moscow, Simonov sat alone in his office, the completed report stacked before him in 3 thick volumes. Outside, the winter had deepened, and the early darkness of December pressed against the frosted windows. He had not slept properly in days, his mind consumed by the implications of what his team had discovered. The report was comprehensive, perhaps the most thorough analysis of a foreign weapon system ever conducted by Soviet military intelligence. It covered every aspect of the M16: materials, manufacturing processes, ballistic performance, reliability under various conditions, maintenance requirements, and tactical implications. It included detailed comparisons with Soviet weapons, statistical analyses of Vietnamese battlefield reports, and projections for how American small arms development might evolve in the coming decades. But the report's most significant section was its conclusion, a 12-page assessment that Simonov had written and rewritten a dozen times, struggling to find language that would convey the magnitude of what his team had discovered without triggering defensive reactions from senior officials invested in Soviet weapons doctrine. The conclusion began with reassurance. The AK-47 remained an excellent weapon system, well suited to Soviet military requirements and superior to the M16 in several critical parameters. Its reliability under adverse conditions was unmatched. Its ammunition delivered consistent lethality at all combat ranges. Its manufacturing requirements were compatible with Soviet industrial capabilities. There was no immediate need to abandon the Kalashnikov platform or fundamentally redesign Soviet infantry weapons. But the reassurance was followed by warning. The M16 represented a design philosophy that Soviet engineers had not adequately considered, an approach that prioritized weight reduction, accuracy, and ergonomics over the robust reliability that had guided Soviet design for decades. This philosophy had produced a weapon with genuine advantages that could not be dismissed as capitalist decadence or American over-engineering. The Americans had asked different questions and found different answers, and some of those answers were better than the Soviet equivalents. The small-caliber, high-velocity concept was particularly significant. The 5.56mm cartridge had demonstrated that lethality could be achieved through intelligent bullet design rather than brute mass, allowing soldiers to carry more ammunition without sacrificing effectiveness at typical combat ranges. Soviet forces, equipped with heavier 7.62mm ammunition, would always be at a logistical disadvantage in sustained operations. A Soviet soldier carrying 200 rounds weighed himself down with nearly 4 kilograms of ammunition alone. An American soldier with the same round count carried barely 2 kilograms. Simonov recommended that Soviet weapons development programs immediately begin exploring small-caliber alternatives to the 7.62 Tech 39mm cartridge. He suggested that materials research should investigate lightweight alloys and polymers that might reduce weapon weight without compromising durability. He proposed that manufacturing processes should be modernized to achieve tighter tolerances, where this would improve accuracy without sacrificing reliability. These recommendations would eventually bear fruit. The 5.45 39mm cartridge, adopted in 1974 with the AK-74, was a direct response to the small-caliber revolution that the M16 had pioneered. Soviet engineers studied the American approach to terminal ballistics and designed a bullet that would tumble and fragment in tissue, achieving similar wound effects with a cartridge optimized for Soviet manufacturing and logistics. The AK-74 itself incorporated lessons learned from the M16 analysis, improved accuracy, reduced recoil, and better ergonomics, while maintaining the legendary reliability of the Kalashnikov platform. But all of that lay years in the future. On this December evening in 1967, Simonov could only speculate about how his report would be received and what changes it might eventually inspire. He knew that challenging established doctrine was dangerous in the Soviet system, that careers had been destroyed for suggesting that Western technology might be superior in any respect. He had tried to frame his conclusions carefully, emphasizing Soviet strengths while acknowledging American innovations, but he could not predict how senior officials would interpret his analysis. He thought about the American soldiers in Vietnam, carrying their lightweight rifles through jungles that seemed designed to destroy precisely the kind of precision instrument the M16 represented. He thought about the Soviet advisors working alongside North Vietnamese forces, watching the war unfold and reporting back through channels that had delivered the captured rifle now sitting in pieces in his laboratory. He thought about Eugene Stoner, the American engineer whose name appeared throughout the technical documentation, a man he would never meet but whose thinking he now understood as intimately as his own. The M16 was not a perfect weapon. Its reliability problems were real, and American soldiers were dying because of them. But the vision behind the rifle, the audacity to question assumptions that everyone else took for granted, that was something Simonov could not help but admire. The Americans had been wrong about some things and right about others, just as Soviet designers had been. The difference was that the Americans had been willing to try something radically new, to accept the risks of innovation in pursuit of potential advantages. Soviet weapons development was more conservative, more incremental, more focused on perfecting existing approaches rather than exploring new ones. This conservatism had served the Red Army well. The AK-47's legendary reliability was a direct result of prioritizing proven solutions over experimental innovations. But conservatism had costs as well as benefits. It meant that Soviet weapons might always lag behind in certain capabilities, that advantages achieved through bold innovation would belong to others. Simonov signed the final page of his report and placed it in the classified courier pouch for delivery to the Ministry of Defense. Whatever happened next was beyond his control. He had done his job, documented what he had found, and offered his honest assessment of its implications. The rest was politics, a realm where engineers had little influence and less protection. He turned off his desk lamp and sat for a moment in the darkness, listening to the wind outside his window. Somewhere in the world, men were fighting and dying with weapons he had spent his life studying. The rifles they carried, Soviet and American alike, were the products of countless decisions made by engineers and generals and politicians, each choice rippling forward through history in ways no one could fully predict. The M16 had shocked him, not because it was better than the AK-47, but because it was different in ways he had never imagined possible. It had forced him to question assumptions he had held for decades, to see his own work through new eyes. That perhaps was the rifle's most significant impact. Not the battles it would win or lose, but the thinking it would change in laboratories and design bureaus around the world. The Cold War would continue for another 2 decades, a vast competition of ideology and technology that shaped every aspect of global politics. Within that competition, the contest between Soviet and American small arms was a minor subplot, barely noticed by the statesmen who negotiated treaties and the generals who planned for wars that never came. But for the engineers who designed the weapons, it was everything. A lifelong pursuit of the perfect balance between lethality and reliability, between innovation and practicality, between the ideal and the possible. Simonov gathered his coat and prepared to leave. Tomorrow there would be new projects, new challenges, new weapons to analyze and evaluate. The work never ended. It simply evolved, each generation building on the discoveries of those who came before. The M16 was now part of that legacy, a data point in the endless accumulation of knowledge that drove military technology forward. He paused at the door and looked back at his darkened office, at the desk where he had spent so many hours trying to understand a weapon designed by men he would never know for soldiers he would never meet. The rifle itself was back in the laboratory, disassembled and catalogued, its secrets extracted and documented for future reference. But some secrets could not be captured in reports and specifications. Some truths could only be understood by holding the weapon in your hands, feeling its weight and balance, sensing the intentions of its designers through the language of metal and polymer and precision engineering. The M16 had spoken to him in that language, and he had listened. What he had heard would change Soviet weapons development forever. And somewhere in America, Eugene Stoner was probably working on his next design, pushing forward into territories that Simonov could not yet imagine, asking questions that had not yet occurred to anyone else. The competition would continue. It always did. The impact of the Soviet analysis of the M16 unfolded slowly, filtered through layers of bureaucracy and institutional resistance, before finally reshaping the weapons that Red Army soldiers would carry into the final decades of the Cold War. But unfold it did, in ways that Simonov could scarcely have anticipated when he submitted his report in that winter of 1967. The first and most visible change was the development of the 5.45 539mm cartridge, a direct response to the small-caliber revolution that the 5.56mm NATO round represented. Soviet ballisticians studied the American approach to terminal ballistics with obsessive attention, dissecting captured ammunition and analyzing wound reports from Vietnam until they understood precisely how the lightweight bullet achieved its devastating effects. Then they set about creating a Soviet equivalent that would deliver similar performance while remaining compatible with Soviet manufacturing capabilities and logistics systems. The resulting cartridge was not a copy of the American round, but an independent solution to the same problem. The 5.45mm bullet featured a hollow air pocket in its nose that shifted the center of gravity rearward, causing the projectile to tumble rapidly upon impact with soft tissue. The effect was similar to the 5.56mm fragmentation, producing severe wounds that incapacitated targets quickly and reliably. But the Soviet bullet achieved this through different means, reflecting the distinct engineering traditions and manufacturing constraints of the two superpowers. The AK-74, chambered for the new cartridge, entered service in 1974 and gradually replaced the AK-47 as the standard Soviet infantry rifle. It incorporated numerous improvements inspired by the M16 analysis: better sights, reduced recoil, improved ergonomics, and tighter manufacturing tolerances that enhanced accuracy without compromising reliability. The rifle retained the legendary durability of the Kalashnikov platform while addressing some of the criticisms that the M16 comparison had highlighted.